back to my class. So we'll quickly look at radioactivity without wasting much of our time. An atom of an element consists of an atom. We'll give you the diagram when I come to class. An atom consists of a small nucleus. Then that small nucleus contains what? Positive charge in it. And it's surrounded, the nucleus itself is surrounded by electrons. And these electrons are negatively charged. Now the nucleus itself is composed of protons, one positive charge, and neutrons, 0 charge. The atomic number of an element is the number, take note, the atomic number of an element is the number of protons in the nucleus, whereas mass number is the total number of neutrons and protons. Atomic number is the number of protons. Is the number of protons in the nucleus, just protons alone. While mass number is that of total number of both neutrons that we say they are neutral, they have neutral charge or 0 charge, neutrons and protons. Then a nuclide is an atomic species with given atomic number and mass number. Isotopes, for example, they are nuclides. They have the same atomic number but different mass number. We have defined what atomic number is and what a mass number is. So isotopes, they have the same what? They have the same atomic number but different mass number. Now most elements which occur in nature are mixture of isotopes. Isotopes of lighter elements are stable, but isotopes of most heavy elements are unstable. Isotopes of light elements are stable, but that of heavy elements, most heavy elements are unstable. These unstable nuclides undergo spontaneous decay. There's something known as a decay time. You know, spontaneous decay to produce stable nuclides by a process called radioactive decay. Now, want to know what a decay is? Decay is accomplished by emission of energy in the form of radiation. Decay is accomplished by emission of energy in the form of radiation. The half-life of a radioactive substance is the time that is required for the isotope to decay to have its activity. That is the half-life of a radioactive substance. Now, we'll now look at radiation. Radiation from an atom or its nucleus may either be particulate or electromagnetic. Radiation from an atom or its nucleus may either be particulate or electromagnetic. Now let's look at particulate radiation. Particulate radiation. This consists of small particles of nuclear fragments. It consists of small particles of nuclear fragments. These are of two types. We have the alpha decay and the beta decay. The alpha decay emits alpha particles, which are made up of 2 neutrons and 2 protons. Alpha decay consists of 2 neutrons and 2 protons. While the beta decay, in the beta decay, the nucleus loses 1 neutron and gains 1 proton. Now, the second one we're going to be looking at is the electromagnetic. You know, we say we have 2 types of this radiation. Radiation from an atom or its nucleus may either be particulate or electromagnetic. So, we've looked at the particulate one. We're going to quickly look at the electromagnetic radiation. These can be divided into 2 groups. 1, very low energy and long wavelength. They are called radio waves. Very low energy and long wavelength, they are called radio waves. 2, high energy and short wavelength. These ones are called light waves. So the first ones, which are very low energy and long wavelength, are called radio waves, while the one that has high energy and short wavelength are called the light waves. The radiation with the highest energy are called X-rays. Those ones have the highest energy. They are called X-rays and gamma rays. Now, the gamma rays can penetrate materials which block both alpha and beta radiation. So, we'll look at areas where radiation or radioactivity is applied. In clinical chemistry, radioactivity is used for the estimation of hormones. It's used for the estimation of hormones, drugs, and other substances. which are present in minute, small quantities in body fluids. Radio immunoassay, for example, when we are doing enzyme-linked immunoassay, we have what we call ELISA, enzyme-linked immunoassay. Now, we also have the radio immunoassay, which is RIA, capital letter RIA, is the method of choice for estimation of hormones. I hope we got that. So when we come to the class, we'll discuss more on that. So our next topic will be on deep stick technology. See you in my next class.